So one other thing I want to talk about from this stuff before we get to today, because we're going to look at the properties and stuff. But remember when we were doing this here, these are our limits of integration, right? And if we're going left to right, our change in x is positive. If we are going from right to left, our change in x is negative, right? And so we're going to use that on here today. All right. This is where we are. Okay. So here are our properties. So if I have a 0 length interval, that means the limits are the same. The limits of integration are the same. Your change in x is what? 0. And you multiply 0 times anything, you're going to get 0. So anytime the limits of integration are the same, the integral is 0. Our basic interval is always going from a to b, so this one goes from b to a, so that's where we're going opposite, right? So it does make the change in x negative, but what we can do so that things kind of all jive together is we're going to factor out that negative, and then that we change this from a to b of f of x dx. So because we know it makes like the whole thing negative, or it changes the sign, so if it was negative, it becomes positive. If we have a constant multiple, so we have some constant, k, multiplied by our function, dx, that we're integrating here, this gets factored out as well, so we get k times the integral from a to b, f of x dx. Now, not every property of multiplication, addition, division, they don't all transfer over, so that's why we're writing them all out separately, or we could say we can treat it just like anything else. We can add integrals by adding intervals. So it says if c lies between a and b, so c is some number between a and b, then the integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b f of x dx. Okay. That's like saying going from 0 to 5 is the same as 0 to 2 plus 2 to 3. Just adding the pieces together, which we did when we found the 2 triangles and areas and stuff yesterday. All right, so notice we can take 2 intervals or 2 integrals and add them together. But if inside of an integral I have 2 functions that are either added or subtracted together, I can split that as well. So this can go from a to b, f of x dx, plus or minus, depending on what's going on, the integral from a to b of g of x dx. Now here's what we can't do. Notice here, if I have 2 functions added inside of an integral, I can separate it into 2 integrals. If the 2 functions are being multiplied, I cannot separate that into 2 integrals that are being multiplied. This is a big fat no. Same thing with division. If I have division going on the inside, I do not get to change that to 2 integrals that are being divided. So this is a big fat no. So the multiplication works only if it's a constant, and then addition and subtraction, but no division, and no multiplying the functions. Well, I mean, you just can't rewrite it this way. This is just the wrong way to rewrite it, is what it's saying. I mean, you can still integrate this, and we can do stuff with it. It just takes other rules that we're not at yet. Okay. You with me, Cameron? Mm-hmm. All right. So let's look at how we can use these properties. So we're given a few things. We're given that the integral from 0 to 3 of f of x dx equals 4, and from 3 to 7 of f of x dx equals negative 1. So we have we're looking for the integral from 0 to 7. And we don't know what the function is, so we can't actually find the areas like we were doing. We're going to use our properties. So if I integrate from 0 to 7, that's the same thing as integrating from 0 to 3, because they gave me that, right? I have to use this stuff somehow, of f of x dx, plus integrating from 3 to 7 f of x dx. You agree with that? Understand how that works? 0 to 3, 3 to 7, that gets me 0 to 7. I know what these 2 pieces are. The integral from 0 to 3 is 4, plus from 3 to 7 is a negative 1. So my answer is 3. So it's about rewriting it from here to here. Any questions? All right, so on B, integrating from 3 to 7, 2 times f of x dx, what can I do with this 2? Take it out, factor it out there. So I get that's equal to 2 times the integral from 3 to 7 of f of x dx. Okay, so that's 2 times, and then I know what this is. That's negative 1, so I get negative 2. We good with that? We have the integral from 5 to 5 of f of x dx. What's that? 0. So this is where we can write limits of integration are the same. Good? All right. So now I'm integrating from 0 to 3. So I have a 0 to 3 up there, but just of f of x, and then it's plus 4. So remember, if I'm adding two things, I can split them. So this is going to become the integral from 0 to 3 of f of x dx plus the integral from 0 to 3 of 4 dx. Right, because I have f of x plus 4, so I can split those into 2. Notice when I split them, there has to be a dx on each one of them. All right. Do we know what this value is? 4. They gave it to us, right? It's that right there. It's 4. So this is equal to 4 plus, and then I have to figure this out. Okay? So let's think about what this means. When you see the integral, it's an area concept. We are looking for the area under the curve, right? The function value times the change in x. So if it helps for you to sketch it, then this is basically just 4. It's y equals 4. It looks like this, right? And I'm going from 0 to 3. So how do I find that area? Base times height. This area is constant, so this is a constant, so that means the height is constant. Where here, this varies. F of x goes up, down, whatever. We don't really know, like, it's not necessarily a rectangle, maybe it is, we don't know. But I'm going from 0 to 3. I have a constant height, so it's just base times height. The base is 3 times 4. So notice that if this is a constant, it's the change in x. So it's not always the top number. The change in x, which is from 0 to 3, 1, 3. 3 times 4, that gives me the 12. So I get 4 plus 12, and I get 16. We okay with that? What questions you got? We good? All right. So I'm going from 7 to 0. I want to flip that around, right? So we want to go from least to greatest. So if I change this to the integral from 0 to 7, what else do I need to do? Negative. And this is going to be 1/2 times f of x dx. All right. Then what else do I need to do? Take the 1/2 out. So this is equal to negative 1/2 times the integral from 0 to 7 f of x dx. Do I know what this part here is? What is it? How do you know? Because we figured out an A. So this is negative 1/2 times 3, and this is from A, which gives me negative 3. You wouldn't have to say, hey, I got this from part A. I'm just doing that on your notes so everybody knows where it came from. Everybody okay with all that? We good? All right. So we are integrating then from 0 to 7, so I have f of x minus 2. So I'm going to split this into 2, right? So I'm going from 0 to 7, f of x dx minus the integral from 0 to 7 of 2 dx. Everybody understand how to split it up, right? What I did and why. Okay. So do we know this first part? Yes, that's from A again, right? It's 3. Minus, now we could graph it again, but remember, this is a horizontal line, so our height is constant. Our base is the change in x. What's the change in x? 7, because I'm going from 0 to 7. So it's minus 7 times 2. It's 3 minus 14, negative 11. What questions do you have? We're all good? Anything? Okay. All right. So it says these properties work in all situations, even ones that don't have function notation, because that was all our function notation. Take the following problem. It is a fact that the integral from 0 to pi of sine of x dx equals 2. With that information, what do you know about, and what you know about integrals and area, what you know about graphing curves, determine the values of the following integrals. So it's trig. That does not mean that it gets any more difficult. You have to have a basic understanding of what the sine graph looks like. What does it look like? A circle. No. The unit circle has your trig stuff. But if we graph sine and cosine itself, what does it look like? Like this, like a squiggle, right? So, and sine is the one that starts here. It goes like this, right? For the parent function, one cycle of sine goes from 0 to what? To pi, right? That's one period, and so then that makes this pi, right? So what this is saying is we are integrating from 0 to pi sine of x dx, so this area is 2. That make sense? That's what it's telling us. So then, if I'm going to integrate from pi to 2 pi of sine, what's it going to be? Negative 2. Why? Because it's area under the curve, or below the x-axis. Very good. So it's negative 2. Does that make sense? Remember, above the x-axis and going from left to right is positive. Below the x-axis is negative. All right. What about going from 0 to 2 pi? 0, because this would be 2, this would be negative 2. It zeroes out, right? It's going to cancel it out, so that is equal to 0. What if I integrate from 0 to pi over 2? 1, because it's half of that, right? Because we're going from, I mean, it's exactly half because we know what it looks like. So it's 1. What do we think about number 4? Could we rewrite this? Yeah, let's rewrite this. Let's get, that is the integral from 0 to pi of 2 dx plus the integral from 0 to pi of sine x dx. Okay. Then we have to think about what we have. This is a constant. So my y value is constant. That's the height of my rectangle, right? This is the height of my rectangle. And I know it's a rectangle because it's constant. This is clearly not a rectangle, right? So the height is 2. What's the base of the rectangle? Pi, because the change in x, we go from 0 to pi, it's pi. So this integral is what? 2 pi. Plus, what is this? 2. Yeah, you can leave it like that. You don't need to factor it out or anything. And we can't, does not become 4 pi. Everybody okay with where everything came from? Ask me a question if you're not. Where'd the pi come from? Okay. So this is like, and if we want to, you can always sketch it if you need to. This, my function is y equals 2. Looks like this, right? Y equals 2, right? My change in x, I'm going from 0 to pi. So because this is a horizontal line, my y value, this is at 2. The height is 2. The base is pi because the change in x is pi. Okay, make sense? Anything else? All right. So I'm going from 0 to pi to sine x dx, and it's 4. Right? Because we can factor the 2 out. Like, we don't actually have to show that we did that, but if I factored this 2 out, then that would be 2. I end up with 2 times 2. All right, number 6. So it's not the sine of x, it's the sine of x minus 2. So I want you to think about transformations. So we have sine of x as a parent function. Sine of x minus 2, what happens to it? It's moved to the right 2. Does that make sense to you? All right, so that means that what we had here that looks like this, we now have as, so here we have, so this is now starting at 2, right? This is supposed to be 2 pi, so this has to be 2 pi plus 2, right? So I want the integral from, that's just pi plus 2, and this is 2 pi plus 2, but I'm going from 2 to 2 pi plus 2, so this would be 2 to pi plus 2, right? Isn't that the exact same areas at the beginning? So think about this too. You can rewrite this, and sometimes it's helpful to think through it this way, sometimes it's helpful to rewrite it. If I'm going to translate to the right 2, and I'm starting at 2 and ending at pi plus 2, then I can say, all right, instead of moving to the right 2, let's move back. So if I take 2 and subtract 2, this is 0 to pi of sine x. Oh, that's sine of p. Sine of x dx. You can kind of shift it back. So those are equivalent, whether you reason through it with translations graphically or this way. Okay, so we move to the right. I want my integral, my limits of integration to move back to the left, so I subtract 2 from here and here. I end up with this, which is still just 2. We good with that? All right. Negative pi to pi. 0, because your function, right, this looks like this, and this goes from 0 to pi. This would be negative pi, and those just 0 out, and it's 0. 0 to pi for cosine. Just think about what we know here. Here's sine, right? What our sine curve looks like. We're looking at areas. Cosine, are they pretty much the same curve? One is just translated, right? So cosine starts here. We'll come down here like this. Something like that's kind of where it overlaps there. So if I'm going from 0 to pi, right here, what do you think that area is for cosine? 0. You got this, and that's just going to 0 out. Do you see that? Take a second. Do we see how that works? And that is 0. What questions you got? We good? No questions at all? All right. So let's talk about even and odd functions, which we talked about a little bit last year. You may or may not have talked about them in Algebra 2. I don't really remember. I think that changes from year to year. But if you have an even function, it has y-axis symmetry. So it could be like a parabola. Y even is y-axis symmetry. Okay? Like, think about y equals x squared. That's an even exponent. Just because it has an even exponent doesn't make it even, but that can make you help you make sure you understand the y-axis symmetry here. Okay, so if I have, let's say this is at negative a, and this is at a, okay, whatever they are. then since it's even, it has that y-axis symmetry, the area under the curve from negative a to a, well, it's symmetric, so I basically just have one of them and I can double it. So that's equal to 2 times the integral from 0 to a f of x dx, or 2 times the integral of negative a to 0 f of x dx. Right? So if I want this whole area, I can either find this one and multiply it by 2, or I can find this one and multiply it by 2. And hopefully that makes sense because of symmetry. Right? We're okay with all that? All right. So then if it's odd, it has origin symmetry. So sine is an odd function. Has origin symmetry. That means we could rotate it 180 degrees and it looks exactly the same, right? You rotate it about the origin. So if this is negative a and this is a, then if I integrate from negative a to a, what's that going to be? 0. Ask me a question. No? Don't tell me no. You have a question? You sure? Oh, okay. Wake up. All right. Any questions at all? All right, so this says we're given f of x is even. So if it's even, it has y-axis symmetry. And we know if we integrate from 0 to 5 of f of x dx, we get 3. Okay? So then negative 5 to 5 of f of x dx is equal to 2 times the integral from 0 to 5 of f of x dx. And then that's going to give me 2 times 3, which is 6. Are you okay with that? No? Ask me a question. I use that because since it tells me it's even, like I can't just always do that, right? And if I'm going from negative 5 to 5, right, if these are just opposites of each other, then I can just double one side of it. So basically, and I probably should have clarified this, this is all the information we have. So we have to figure out somehow to use this to find this. Yes, because it says even, we know we can double. Okay. All right, so what do you think about the integral from negative 5 to 0? What would that be? 3. And then, let me just put it, it's because it has a y-axis symmetry. All right, so here we have this 4 times this, so I can rewrite this as 4 times the integral from negative 5 to 5 of f of x dx. Do we already know what this is? 6, because we found it in A. So we really just get 4 times 6. We're good? All right, so this is odd, which means it has origin symmetry, which means it's going to cancel out, right? And so if I'm going from 0 to 5, and I know that this is 3, if I'm going to go from negative 5 to 5, what's it going to be? 0. What would it be from negative 5 to 0? Negative 3. So we don't know what this function looks like, but you can think about sine just to be like your generic odd function to think about it. If this is 3, then this is going to be negative 3. Does that make sense? Okay. And again, I'm not saying that this is a sine function, but it helps you wrap your mind around the odd. All right, and then here, this would be 4 times the integral from negative 5 to 5 of f of x dx. Did we figure this out? Yes, it's 0, so this is just 0. Any questions at all? All right. So this says if f of x is odd, and we know these two things, or I'm sorry, we know this, we're looking for the integral from 4 to 7. Okay, so I'm just going to rewrite that. I'm going to say, okay, I want the integral from 4 to 7 of f of x dx. All right, so I have to figure out how to use this somehow to help me find this. Well, they're giving me the integral from negative 4 to 7. I just want it from 4 to 7. So I need to get rid of the part that goes from negative 4 to 4. Does that make sense to you? Because we're going from 4 to 7 is all I want. It starts at negative 4. So I can say this is equal to the integral from negative 4 to 7 f of x dx, right? And then I want to subtract from it part of it. I don't want the part, I only want to go from 4 to 7. So I have to get rid of the part that goes from negative 4 to 4 f of x dx. So let that sink in for just a second. Right? So if you think you're on the x-axis, right? I'm going from negative 4 to 7, right? That's what all this is. I only want to go from 4 to 7, so I have to get rid of that part. Okay? That's what's happening here with these limits of integration. Now, since it's, okay, so they give me this part, right? They give me this. This is 5. This is equal to 5 minus, and then if it's odd, and I'm integrating from negative 4 to 4, what's this integral? 0. So my answer is 5. Do you see how to manipulate those to split them up? Okay, because we're going to have to split them up, put them back together, you know, depending on what we're trying to do with all this. So let's look at this next one. F of x is even, and we know these things, and we want to find the integral from 2 to 5. Okay. So we're going to have to figure out how to go from 2 to 5. F of x dx using those pieces there. Let's think about this. I don't know that we're going to be able to add and subtract exactly like we did before. But since it's even, what do we know that we can do with this? What can I find from this if it's even? From 0 to 2? You get 2. Okay. So if I say, so this is what I'm going for in the end, right? But if I say, all right, I know if I integrate from 0 to 2 f of x dx, right? Since it gave me from negative 2 to 2 and it's even, then this has to be half of that, right? Because you only have one side of it. Think about this, right? Think about it being you have negative 2 to 2, but I'm only going from 0 to 2, so it's half of that. So that has to equal 2. I can do the same thing for the other one. I can just say I'm going from 0 to 5 of f of x dx. What would that have to equal? 6, because it's half of it. Does everybody understand why and how that works? Ask me a question. Did this click with you? Okay. Because if I'm going if this is the whole thing, if I only start at 0, I'm only getting half of it, so I was able to divide both of those in 2. Now, by starting at 0 and going to 2 and 0 going to 5, can I do something to get this? Yes, I can take this one and do what with it? Subtract this one. So this is equal to the integral from 0 to 5 of f of x dx minus the integral from 0 to 2 f of x dx. And that would leave me from 2 to 5. And I found these things. I know that this one is 6, so this is going to be 6 minus 2. And my answer is 4. What questions do you have? We're good? All right. On the next one, we want to go from -5 to 5. They gave me two integrals, one that goes from -5 to 2, and one that goes from 5 to 2. Which one of these is backwards? The second one, right? So this takes me from right to left. So I'm going to flip that around. So let's just do that first. So I'm going to go, instead of from 5 to 2, I want to go from 2 to 5 of f of x dx. What would that be equal to? 4. It'd be a positive 4, right? Because I didn't factor out the negative I could have. I could add a negative and -4, and then it just becomes 4. But do you understand why this becomes a positive 4? Because this is going the opposite way, so it changes it. Okay, so now that I have that, I want from -5 to 5, what can I do with these two? Add them together. So the integral from -5 to 5 of f of x dx equals the integral from -5 to 2 of f of x dx plus the integral from 2 to 5 of f of x dx. And then we have those from -5 to 2, that's a -17. And then from 2 to 5, that is 4. So it gives me a -13. What questions you got? Anything? All right. We have one more, which we'll go ahead and finish this. All right, so I'm going from, I have the integral from 0 to 3, and I want to find from 2 to 5. So the first thing I think I want to do is split this up. Okay, does that make sense to split that up? All right, so I'm going to split that up, and I'm going to say, all right, so this becomes the integral from 2 to 5 of f of x minus 2 dx plus the integral from 2 to 5. Now, I have a couple of options here. I can split this up into 3 things, or I can leave this as 1. So I think I'm just going to leave that as 1, like so. Everybody good with all that so far? Okay, so I've split up that double one, and I have to figure out somehow to use that 0 to 3. But before we do that, I want you to look at these two integrals, and the function part of the integral, tell me what's different about the two. That if you don't catch it, it makes it really hard. Notice how this is f of x minus 2? This is not f of 2x minus 1. It's just straight up 2x minus 1. So basically in this one, we know what the function is, right? In this one, I have no idea what the function is. I just know it's been translated. See the difference there? Okay, and I'm pointing that out to you because when I worked this the first time, I was like, I got this part, and then I was like, what the heck with this 2x? I don't have the information for that. I was trying to use this as f of 2x minus 1. Totally not what it says, so don't do it that way. All right, but we can look at this a couple of different ways. This is being translated to the right, yes? So since it's being translated to the right, if I want this to just be f of x dx, what would these become? 0 to 3. And then do I know that part? I do totally know that part, okay? So let's talk about the second part here. Because on the second part, I don't have an f of x, I have the function itself, that means I have to actually go find that, right? So that means I need to find the area under the curve that they gave me the function of. So this is 2x minus 1. So it looks something like that, right? Because negative 1's down there and it's positive slope. And I'm going from 2 to 5. So on this one, I'm not changing it from 0 to 3 because I'm not thinking about it as a translation any which way. So if I substitute 2 into here, what do I get? 3. So I'm going to start here, 2, and then this will be 2, 3. And then I go all the way to 5. And when I substitute 5 in, what do I get? 9. So this is 5, 9. Right? So this is what I'm finding the area of. What is that thing? Trapezoid. So I do the area is equal to 1/2, and then I need to add the base lengths. What's my first base length? 3. Plus the second one is 9. The height of the trapezoid is 3, because it's the distance between the bases. So that's 12. Half of 12 is 6 times 3 is 18. And so this is, just put 18 here, I guess, once we do it. And then what is this value here? 8. So this is really just 8 plus 18. Oh, no, it's not. 26. I can't add. 26. What questions do you have? Anything? All right, so I want you to practice some on these before I see you tomorrow.